What if I told you that the vast emptiness at the edge of our solar system isn't empty at all? For decades, we imagined it as a quiet, lifeless frontier, a distant zone with nothing to teach us. But Voyager proved us wrong, revealing cosmic mysteries, unseen forces, and a universe far more dynamic than anyone expected. These discoveries challenge everything we thought we knew about space, pushing humanity to rethink our place in the cosmos. Imagine sending tiny machines into the void, and they return with stories that change how we see reality itself. It's counterintuitive. We often assume the emptiest regions hold the least information. Yet, the outer solar system holds some of the most fascinating space facts ever recorded. Voyager's journey gives us deep insights into the heliosphere, plasma turbulence, and magnetic interactions that were once considered unknowable. The paradox is clear: emptiness became a treasure trove, and curiosity turned silence into a profound narrative. This isn't just science for scientists. Understanding these cosmic phenomena affects how we predict space weather, design spacecraft, and even study distant exoplanets. Voyager's findings transform abstract space discoveries into tangible lessons for humanity. It's proof that exploration is not just about venturing out, it's about seeing the invisible, learning from it, and applying it in ways that touch our lives here on Earth. So, if you've ever wondered what lies beyond the familiar planets, what secrets the solar system still keeps, or how tiny human-made machines can illuminate the infinite, you're about to find out. This journey is a testament to the mind-blowing science of deep space exploration, where emptiness turns into a story full of life, energy, and lessons for all of us. Prepare to have your perception of the universe explained in ways that are both astonishing and deeply human. The Voyager spacecraft were humanity's bold attempt to reach the edge of the solar system, venturing into regions no one had ever explored. Scientists expected predictable measurements of the solar wind and a static heliosphere, but what the Voyagers found was far more complex. Changes in speed, density fluctuations, and signals from an active frontier revealed that space discoveries were about to rewrite textbooks. It was like sending explorers into an unknown forest, where every data point was a clue, a breadcrumb guiding us deeper into cosmic mysteries. Each observation challenged assumptions. The solar wind's behavior and the plasma density variations showed that the solar system's edge is not a quiet boundary but a dynamic, evolving environment. These insights brought Universe Explained into focus, turning abstract science explanations into tangible experiences for anyone following space education videos. The idea that human-made machines could touch the outer limits of our star system was mind-blowing science in action. Voyager's journey reshaped our understanding of exploration itself. By observing these unexpected changes, scientists gained a glimpse into processes that were previously theoretical, deepening our knowledge of fascinating space facts. It's a story of human curiosity, ingenuity, and the thrill of discovering the unknown. Each measurement was like a note in a symphony of cosmic phenomena, guiding us through uncharted space. The discoveries also raised profound questions. How representative are Voyager's readings of the solar system's frontier as a whole? Can a few spacecraft truly map the dynamic complexity of this distant region? These uncertainties didn't diminish the achievement, they highlighted the challenges inherent in deep space exploration. Observing the solar system's boundary taught us that curiosity requires patience and humility, even when mind-blowing science is at our fingertips. Sending Voyager into the void was an existential leap for humanity. For the first time, we placed machines capable of venturing into the unknown and returning knowledge that reshaped our cosmic perspective. These spacecraft became extensions of human curiosity, instruments of discovery traveling farther than any human could reach. Each signal they sent back is a testament to our desire to understand the universe, bridging imagination and reality. The data Voyager sent home continues to inspire. From the velocity shifts in the solar wind to subtle plasma anomalies, every reading contributes to a larger picture of our cosmic environment. It's a reminder that space storytelling isn't just about planets and stars, it's about the invisible forces shaping the universe, teaching lessons that ripple across science, philosophy, and human understanding. The heliosphere is like the sun's living shield, a dynamic bubble protecting our tiny planet from the harshness of deep space exploration. Scientists once imagined it as a simple, static barrier against cosmic radiation, but Voyager's data revealed a pulsating, reactive frontier. The observations showed expansion, contraction, and interactions with the surrounding interstellar medium, turning basic astronomy explained into a fascinating exploration of cosmic phenomena. It's like seeing a balloon adjust to invisible pressures, constantly reshaping itself in ways that are both subtle and dramatic. Understanding this protective shield has immediate implications for space discoveries. The heliosphere modulates cosmic rays that could impact Earth, offering a first line of defense in the universe explained. Think of it as a living armor, not fixed but responsive, teaching us that even protective forces in space are more complex than we imagined. Space education videos can illustrate this beautifully, showing viewers that what seems invisible is actually alive with activity. The dynamic behavior of the heliosphere challenges our assumptions and invites curiosity. Each expansion and contraction raises questions about how the Sun communicates with interstellar space, like a heartbeat sending ripples across a cosmic pond. These variations are a reminder that cosmic mysteries are not static, they evolve, interact, and surprise us. For those fascinated by space storytelling, this is a perfect example of nature's intricate choreography. Imagine standing at the edge of a vast, invisible shield that stretches billions of miles, breathing and pulsating with the Sun's energy. Voyager's instruments provide data on how this bubble responds to solar cycles, revealing a dance of forces that protect our world. This interplay between solar wind and interstellar medium offers mind-blowing science for anyone curious about universe facts. It's a story of balance, resilience, and the delicate connection between our star and the surrounding cosmos. The heliosphere's fluctuations also offer practical insights. By understanding how it modulates cosmic radiation, scientists can better predict space weather events, critical for protecting satellites, astronauts, and even electrical grids on Earth. The dynamic nature of this shield reminds us that our planet's environment is intimately linked with these distant cosmic phenomena. Deep space exploration isn't just theoretical, it has real-world relevance and teaches lessons about adaptability and vigilance. Even with detailed measurements, questions remain. How does the heliosphere behave during extreme solar events? Are there surprises lurking at its outer boundary? Each answer from Voyager opens a new chapter of inquiry, revealing that our protective bubble is far from fully understood. Fascinating space facts emerge not only from what we observe but also from the mysteries that remain, fueling the next generation of curiosity and discovery. This insight into the Sun's dynamic shield reshapes how we think about cosmic protection. It's not a static wall but a responsive, pulsating boundary that interacts with forces we're only beginning to understand. The heliosphere reminds us that universe explained is always evolving, and each discovery enriches our grasp of cosmic phenomena. And as we track its behavior, we naturally wonder what awaits just beyond, nudging us toward the next chapter of exploration. At the edge of the solar system, the Voyagers encountered what scientists now call the Wall of Fire, a sudden spike in plasma temperature reaching 30,000 to 50,000 Kelvin. This wasn't the gentle transition they had expected, it was a shockwave of cosmic phenomena, revealing that deep space exploration is full of mind-blowing science. The instruments recorded turbulent, compressed plasma, painting a vivid picture of a frontier far more hostile than textbooks ever suggested. Imagine walking into a wind so hot it could melt ice without you feeling the heat, a silent fury of the universe. Scientists initially thought the transition from the solar wind to interstellar space would be smooth, predictable, like turning a page in a calm book of astronomy explained. Voyager's data shattered that notion, showing abrupt energy peaks and complex turbulence. Each anomaly is a lesson in cosmic mysteries, a reminder that even seemingly empty space is alive with motion and energy. Fascinating space facts emerge in these extremes, highlighting the unpredictable heartbeat of our solar system's frontier. The plasma's behavior has profound implications for space discoveries. It illustrates that the edges of our system aren't a gentle fade but an active, energetic boundary that can influence spacecraft and future missions. Understanding this phenomenon helps us anticipate conditions in deep space exploration, from radiation hazards to particle density variations. It's like preparing for a storm you can't see but know will test every skill and tool you have. Voyager's observations transform abstract science explanations into a tangible reality. The Wall of Fire acts as both a warning and a guide, showing where energy peaks and turbulence dominate. It's a frontier that challenges human curiosity, inviting reflection on the sheer scale and power of cosmic phenomena. Space education videos often focus on discoveries, but this is a case where the process, the struggle, the turbulence, is just as mind-blowing as the results. Analogies help us grasp the wall of fire. Picture invisible flames stretching across billions of kilometers, shaping the solar system's outer boundary. Just as explorers might navigate volcanic terrain without feeling the heat directly, the Voyagers chart this plasma landscape through indirect measurement, revealing patterns in chaos. It's a dance of energy, turbulence, and force, illustrating how universe explained can be both beautiful and dangerous at once. Despite the detailed data, much remains unknown. The extreme temperatures and sparse measurements leave scientists with tantalizing uncertainties. Each reading prompts new questions. How uniform is this phenomenon across the boundary? How does it interact with the heliosphere and interstellar medium? These mysteries highlight that deep space exploration isn't just about reaching points in space, it's about uncovering the invisible forces shaping the cosmos. The Wall of Fire also offers a humbling perspective on human ingenuity. To send instruments capable of surviving and transmitting data through such conditions is a testament to our curiosity and engineering prowess. It's a story of confronting invisible energy, of learning about cosmic phenomena firsthand, and of realizing that the universe holds far more surprises than we could ever imagine. And as we look beyond this wall, it naturally leads to the next frontier, where magnetic fields and unseen forces await discovery. As the Voyagers ventured further, they entered a region where the Sun's magnetic field and the galactic magnetic field seemed to dance together. Scientists expected abrupt shifts, a jarring change in direction, but instead, the fields aligned almost parallel, flowing smoothly like rivers side by side. This subtlety is a perfect example of cosmic mysteries at work, revealing how universe explained can surprise even seasoned researchers. Observing these magnetic fields in such harmony offers fascinating space facts that make the invisible forces of the cosmos feel almost tangible. The alignment challenges previous models, forcing scientists to rethink how magnetic fields interact at the solar system's boundary. It's as if two vast energies, each with its own rhythm, are negotiating space silently, a choreography we are only beginning to interpret. Deep space exploration here becomes less about brute force and more about understanding the quiet language of energy in motion. Space storytelling thrives in these moments, where subtlety conveys as much drama as explosive phenomena. Voyager's instruments revealed that the transition isn't violent but smooth, almost like two streams merging gently rather than clashing. It's a reminder that the cosmos has a hidden order, a structured complexity that eludes casual observation. Mind-blowing science often lies in these details, where careful measurement uncovers patterns invisible to the naked eye. For those seeking space education videos, this alignment offers a perfect story of discovery through patience and precision. Analogies bring this phenomenon closer to our understanding. Imagine two rivers flowing side by side, sometimes brushing, sometimes diverging, but never colliding harshly. That's what the sun's and galaxies' magnetic fields do, a silent dance of energies billions of miles wide. Observing this interplay teaches us that universe facts aren't always obvious. Sometimes, the most profound discoveries come from noticing the subtle movements of forces beyond our perception. This magnetic dance also underscores the importance of Voyager's journey for future exploration. Understanding how these fields interact could influence how we design spacecraft, protect electronics, and anticipate cosmic radiation. It's a practical lesson hidden within an abstract phenomenon, showing that cosmic phenomena have both theoretical and real-world implications. Every aligned vector and every gentle curve of the field tells a story about the hidden architecture of our cosmic neighborhood. Even with these insights, uncertainties remain. Scientists still struggle to fully model why the transition is so smooth and predictable. Each new data point opens fresh questions about the interaction between solar and galactic forces, reminding us that deep space exploration is a dialogue with the unknown. These mysteries inspire curiosity and emphasize that universe explained is never final, it evolves as our tools and observations improve. The intertwined fields evoke a sense of awe and existential reflection. Here, at the threshold of our solar system, the cosmos demonstrates both power and elegance, a harmony that resonates with our desire to understand and explore. It's a vivid illustration that in space storytelling, the most captivating moments often emerge where science meets subtle beauty. And as we move beyond these magnetic flows, the next frontier, the dynamic dance of solar and interstellar winds, awaits. At the frontier of the solar system, the solar wind meets the interstellar medium in a delicate, yet powerful, dance. Scientists once expected a simple, predictable shock, like waves crashing against a shore, but Voyager revealed a far more intricate performance. Compression, turbulence, and continuous motion dominate this invisible collision, showcasing mind-blowing science that transforms our understanding of deep space exploration. Every measurement is a snapshot of cosmic phenomena, a story of forces interacting silently across billions of miles. The interplay between solar and interstellar winds highlights the complexity of cosmic mysteries. These forces shape the heliosphere, influence cosmic ray propagation, and create patterns that challenge conventional astronomy explained. It's like observing two seas collide smoothly, forming unseen waves that ripple across space, affecting everything in their path. Fascinating space facts emerge when we look at these subtleties, demonstrating that space discoveries aren't always about dramatic explosions, they're often about hidden rhythms. Voyager's data show that this boundary is dynamic, constantly responding to changes in solar activity. Solar storms, magnetic field shifts, and plasma fluctuations create a living interface, reminding us that universe explained is a continuous story, never static. These observations provide essential insights for space education videos, showing how interstellar forces can influence our understanding of radiation exposure and spacecraft design. It's a lesson in the interconnectedness of cosmic phenomena and human exploration. Analogies make the invisible more relatable. Imagine two vast oceans merging, their waters flowing together, creating subtle swells and eddies. That's what happens where the solar wind meets interstellar space, a constant, graceful turbulence that Voyager helps us witness. Observing this dance teaches that the universe is full of patterns, even when we cannot see them directly. Deep space exploration is as much about interpreting these patterns as it is about charting new territory. This turbulent interface also informs future missions. Understanding how winds interact can improve navigation, protect instruments, and anticipate radiation hazards for astronauts traveling beyond Earth. It turns abstract cosmic phenomena into practical knowledge, bridging science explanations with real-world applications. Every wave, twist, and compression recorded by Voyager contributes to our ability to safely explore deeper reaches of space. Despite the wealth of data, much remains uncertain. The solar interstellar dance is influenced by countless variables, many beyond our ability to manipulate. Each observation raises questions about the scale, intensity, and variability of these forces, highlighting the limits of our current models. Yet, these very uncertainties fuel curiosity, encouraging scientists and enthusiasts alike to keep exploring the cosmos. The ongoing interaction between solar and interstellar winds also evokes existential wonder. These unseen forces, shaping the boundary of our solar system, remind us of the universe's vast complexity and our small but inquisitive presence within it. Space storytelling comes alive here, blending observation, analogy, and imagination into a compelling portrait of cosmic forces in motion. And as we track this dance, attention naturally turns toward its implications for humanity and the next frontier of exploration. The discoveries at the edge of our solar system carry profound implications for humanity. What once seemed distant and irrelevant now directly affects our understanding of space weather and cosmic radiation. The heliosphere's behavior, mapped by Voyager, provides a template for protecting spacecraft and predicting hazards in deep space exploration. These findings bridge fascinating space facts with practical applications, showing that cosmic phenomena have consequences for our daily lives and future missions. Understanding the solar system's outer limits also helps us study exoplanets and distant star systems. By knowing how our Sun interacts with interstellar space, scientists can infer the behavior of other stars and their planetary shields. Space education videos often highlight this connection, demonstrating that observing our own cosmic backyard informs universe explained across the galaxy. It's a humbling reminder that we are part of a vast, interconnected cosmos. The wall of fire, the magnetic fields, and the solar wind interactions teach us about vulnerability and protection. Our planet relies on a living, responsive shield that adapts to the forces around it. Learning how this boundary works is like understanding a castle's walls, knowing their strength, their weaknesses, and the risks for travelers venturing beyond. Mind-blowing science emerges not just from the data, but from recognizing our dependence on these invisible defenses. Voyager's data also inspire innovation in technology and engineering. Instruments capable of withstanding extreme plasma temperatures and magnetic turbulence pave the way for future missions. They show that deep space exploration is not merely theoretical, it requires practical solutions grounded in understanding cosmic phenomena. Fascinating space facts turn into actionable knowledge, offering guidance for designing safer spacecraft and predicting environmental hazards. These findings evoke reflection on humanity's place in the universe. By observing how the sun's influence interacts with the wider cosmos, we see that life on Earth exists within a delicate balance. Space storytelling here is both awe-inspiring and cautionary, showing that exploration isn't just adventure, it's responsibility. The interplay of forces at the solar system's edge highlights that Universe Explained is vital for both knowledge and survival. Even with all the insights, uncertainties remain. Voyager's observations are limited to two trajectories, countless variations may exist elsewhere at the solar system's boundary. Future missions will be necessary to deepen our understanding and refine predictions. Yet these early discoveries already offer guidance, encouraging curiosity, preparation, and a profound appreciation for the protective systems around us. Ultimately, the edge of our solar system is a mirror for humanity. It reveals our vulnerability, our ingenuity, and our capacity for exploration. The lessons learned from Voyager help us imagine what it takes to traverse other star systems, anticipate cosmic threats, and continue our quest for knowledge. And as we contemplate these implications, attention naturally shifts to the enduring journey of the Voyager spacecraft, still sending messages into the void. Even after decades, the Voyager spacecraft continue their journey, sending signals that bridge the gap between humanity and deep space exploration. Scientists initially expected the missions to fade into silence, but instead, each transmission carries vital data about cosmic phenomena and the outer limits of our solar system. It's a testament to human ingenuity, turning our curiosity into a persistent presence in the universe. Space storytelling here transforms machines into messengers of knowledge and discovery. These enduring signals offer fascinating space facts that inspire both scientists and the public. Voyager has become more than a mission, it's a narrative of persistence, exploration, and our desire to understand Universe Explained. Each bit of data represents a thread connecting us to a frontier few have ever witnessed firsthand. Deep space exploration is no longer abstract, it's an ongoing story of contact, interpretation, and learning. The Voyagers are like silent messengers traveling beyond our lifetimes. Their energy may be finite, but their legacy is immeasurable, carrying insights about magnetic fields, plasma turbulence, and cosmic boundaries. Mind-blowing science emerges not just from what they measure, but from the human curiosity that drove their creation. These tiny machines embody the audacity of humanity to reach the unknown. Their continued operation highlights uncertainties and limitations. Power sources dwindle, instruments age, and eventual silence will come. Yet the lessons they impart remain invaluable. Each observation informs models, inspires innovation, and feeds the imagination of those who dare to ponder the cosmos. Fascinating space facts live on in the minds of those who follow their journey. Voyager's legacy also prompts existential reflection. By venturing into the infinite, these spacecraft hold a mirror to humanity's own quest for permanence, memory, and impact. They demonstrate that exploration is both a technical and philosophical pursuit, connecting engineering prowess with a desire to leave a mark on the universe. Even as signals weaken, the stories continue. Every burst of data is a whisper from the edge of the solar system, a cosmic message reminding us of our place in a vast, dynamic universe. The spacecraft's journey exemplifies that Universe Explained is a shared narrative, spanning generations and illuminating the interplay of cosmic forces beyond immediate perception. Ultimately, the Voyager missions teach us that curiosity, ingenuity, and persistence transcend our limitations. They invite reflection on legacy, discovery, and the ever-evolving story of humanity's place in the cosmos. And as these messengers travel onward, they leave us with one undeniable truth: exploration is infinite, and the universe will always have more to teach us. The journey of Voyager teaches us that curiosity has no limits, and exploration is never truly finished. Every measurement, every signal from the edge of the solar system shows how much there is to learn about cosmic phenomena and the hidden dynamics of our universe. What can you take from this? How might your own curiosity push you to explore unknown frontiers, whether in science, technology, or life itself. The lesson is clear: paying attention to the unseen can reveal mind-blowing science and fascinating space facts. Think about the forces that shape the heliosphere, the wall of fire, and the magnetic fields that dance at the edge of our solar system. They're invisible, yet profoundly powerful, just like ideas that can transform the way you see the world. What if you approached challenges in your life with the same persistence and patience as the Voyagers, navigating turbulence and uncertainty with determination? These are universal lessons, bridging space education videos and personal insight. And here's a question for you: if tiny machines can travel billions of miles and send back messages from the void, what might you be capable of if you pushed beyond your own limits? How can observation, curiosity, and patience shape your personal journey? The Universe Explained is not just a collection of facts, it's an invitation to think bigger, aim higher, and embrace the unknown. Before you go, make sure to subscribe to the channel and activate notifications so you can continue exploring the cosmos with us. Keep diving into deep space exploration, cosmic mysteries, and fascinating space facts. And don't forget, the video on the screen shows the previous journey of Voyager, full of insights you won't want to miss. Your adventure into the unknown is just beginning.